and then get down to the couple of things you'll be choosing between. In multiple choice, there's always going to be two which are like completely wrong and two which are pretty close to right. So you can get it down to a 50-50 shot if you're guessing. So ratio of two sides belonging to the same shape, the ratio of one pair of corresponding sides, the ratio of all pairs of corresponding sides, the change in length of each side, all angles and sides are equal. So I would straight away look at that and go, not all angles and sides are equal because we know that. The ratio of two sides belonging to the same shape, we're usually looking between two shapes, so I'd cross out that one as well. The ratio of one pair of corresponding sides, the ratio of all pairs of corresponding sides, or the change in length of each side. We're usually talking about ratios, so I'm thinking it's going to be B or C. Now, would it just be one pair of sides or would it be all pairs of sides? All pairs of sides, so our answer is C, that's worth 1 mark. Okay, but can you see how you could get it down to being a 50-50 shot? Okay, and that would be better than just picking between 1 in 5. Better to get it down to 1 in 2. All right, calculate the scale factor of the following shape. So how do we find the scale factor? We're finding K, and K is what? Good, the second number over the first number. Okay, so second divided by the first. So for this one, we've got 9 over 3, which is the same as 9 over 3, 3 over 1, which is just 3. Okay, 1 mark. Make sense? Second, so we're going, how do we get from the first one to the second one? Yes. 1 to 3. Scale factor is a number, it doesn't say ratio. How about this? I will give you a mark if you will give it 2 marks. Okay? 1 to 3. Okay, 1 to 3 or 1 to 3, it is the same thing.
Is that 2 marks or 1 mark?
No, it's only worth 1 mark. Okay, so it's either 3 or a ratio of 1 to 3, because it is a ratio. That's okay. All right, next one says, which ones are the corresponding? So which number corresponds to the 4? The 20. Which one corresponds to the 3? The 15. Okay, so make sense of that. Take in a couple of different highlighters. And you can usually say that the smaller one's always going to still be smaller on the other side. Okay, so you could either use the 20 or the 15. So let's go 20 divided by 4 equals 5. Or you could say 15 divided by 3 equals 5. So you could say K equals 5. You'd need to actually write K equals or 1 to 5. Everyone okay with that? All right, next one. What does K equal? Now, it's not 2. It's a half. It's 1 over 2 because it's going to the smaller side. So it's, if we look at it, it's 2 over 4, which is a half. Okay?
Could you write a ratio?
You could write a ratio of 2 to 1.
Wait, could you write 2?
If you wrote 1 to 2, that would be wrong. If you wrote 2, that would be wrong. It has to be in the right order, 2 to 1. Okay, so those questions. So this page should be out of 4 marks. Can you write out a mark out of 4 down the bottom corner? So 4 marks in total. Any questions? All right. Who's whistling? Okay. Use the following information to determine the scale factor K in each case. Now, this is where the question comes in with area. You need to be aware of the word area and the word volume, because K is for length, K is just K to the power of 1. For area, it's K squared, and for volume, it's K cubed. Okay, so the area of an image is 16 times larger than the original area. So we're saying to get from this area of something to here, it's going to be 16. Now, because it's area, it's saying K squared is 16. So therefore, what does k equal? Not 16 times 16, 6, the square root of 16. So k equals 4. Okay, so you need to be aware of that. So we look at the difference between them, but if it's area, it's going to be, that difference is going to be k squared. So we need to be able to work that out. You did have a calculator if you needed to, but you should have known the square root of 16. Okay, area of the image is 1/4 of the original image. So we've got an image, it's 1/4 of it. So it's going to get smaller. So k squared equals 1/4. So again, this one's the tricky one really. We need to find the square root of 1/4, which is half times 1/2. So k equals 1/2. Who got that? Well done, it's tricky. But can you see the process now? Okay, so knowing as soon as you see the word area with scale factor, you need to know that it's k squared, whatever the change is. Okay, so the volume of an image, so we've got an image here of volume. Okay, so it might be the inside of that. When we change it, gets to 125 times. So is it k? Oh, sorry. How long's that been off for? Okay, I was going to say. So 125. So is it, what does that 125 represent? Does it represent k? Does it represent, what does it represent? It's larger by 125 times, and it's k to what? The power of 3. 13, 17. All right, so it's k to the power of 3. Oh. Don't know what I just did then, but anyway. So 125 is k to the power of 3. So how do I find k? It's not the square root, it's the cubed root. And so k equals 5. What that means is if you had a cube, which was 1 by 1 by 1, let's try this out to show you that it works. If you had a cube, which is 1 by 1 by 1 by 1, then it'll be, the volume would be equals 1. If I times this all by k equals 5, if I make it a cube which is 5 by 5 by 5, so I've made all the lengths 5 instead of 1, what does the volume become? Equals 5 times 5 times 5 times 5, which is 125. So this would be 1 cubic centimetre, this would be 125 cubic centimetres. So k is 5 because we increased all the lengths by 5. But if we were just looking at the volumes of them, you actually have to times by 5 to the power of 3. And that's why this works in that way. Any questions? So you need to be able to know those so that the volume means k cubed. The circumference of a circle, so circumference of a circle is the outside. Is that length? Or is that area? Or is that volume? So this is the story. The circumference has changed from 15 centimetres to 45 centimetres. The circumference. Is circumference, what's circumference? It's a length, yeah? It's the outside length. Good. So, therefore, how do we get from 15 to 45? We times by 3. So 15 divided by, so 45 divided by, so k equals 3. It's not k squared, it's not k cubed because it's length, it's just k. All right, sorry, marks wise. I'll give you a mark for the k squared equals 16. I'll give you a mark for 16 and a mark for 4. I'll give you a mark for 1/4 and a mark for 1/2. I'll give you a mark for 125 and a mark for 5. And then for this one, you just get a mark for the 3. So this should be out of 7, this page. Everyone okay?
What was B again?
For B, a quarter and a half. However, if you got, for any of these, if you got K equals 4, you get 2 marks. If you got K equals a half, you get 2 marks. If you get K equals 5, you get the 2 marks because there's no. Yeah, that's 0.25, you get 1 mark. All right, any questions? Alex, Colby, what you doing? All right, keep going. Okay, determine which of these shapes are similar. So how do we know if shapes are similar? What do they have to have? There's 2 things. They have to have, say again. Corresponding, now there's a word we need to make sure we know in that. With the same, corresponding sides with the same ratio. Good. There's one other thing we need to have. Angles have to be the same. Those are the 2 things we need to know if shapes are going to be similar. Angles are the. All right, so if we look at this, we can't find the angles, but let's just assume that they're. All right. If we look at this, this question I would actually go, they're all not similar. Well, we can't prove they're all similar. Why not? Because we don't know the angles. Okay, however, we're going to assume that those angles are the same. But if you said that, if you wrote none of these are similar because you can't tell the angles, I will give you 2 marks because that's correct. We didn't put it in the question. Okay. However, let's assume that they are the same. So let's look at A and B. If we look at A and B, where are some corresponding sides? Or what's the corresponding side to the 4 centimetres here? 8 on that one. And what's corresponding on C? 6. Okay. And then let's try another one as well. So let's go with the 6. Oh, sorry, that's the wrong colour. Let's go with 6. What's corresponding to the 6? 10 and 9. All right, so we'll start with them. If we need to, we'll keep moving. Okay, so A and B, A to B, if we look at the ratio of 4 to 8, is it the same as the ratio of 6 to 10? So if we actually write it, if I write it in a different way, if I go as fractions, if I go 8 divided by 4, is it equal to 10 divided by 6? Is it the same thing? If I simplify it down, would it be the same thing? No. So therefore, A and B are not similar. That's worth 1 mark. Okay? A and B are not similar because if we look at those 2 ratios, it's not the same. If we then look at A and C, and we go, okay, 6 divided by 4, is it the same as 9 divided by 6? So I'm going the blue and the yellow. Yeah. Is it the same? Yes? Okay, now if I try another one, is it the same as, sorry, we're A and C. 15 divided by 10, is it the same? Yeah. Yep. And is it the last one, 12.75 over 8.5? It is. So we're going to say A and C are similar. That's worth a mark, and you're working out as worth a mark of showing at least 2 sets of sides are the same. You should show all of them though.
What if it's only 1?
Pardon? If it's only worth 1 mark, then AC are similar is fine.
No, what if it's only 1 side?
You need to prove, so the whole point is with any similar shapes, you need to prove that all sides are in the same ratio and all angles are. Okay? So far we're at 3 marks. We're going to do 4 marks as well. So then we need to compare B and C. So I've got, and as soon as you've got one which isn't, then you know it's not. So the reason why we kept going after two sides was that it was working. Okay, so we'll go 9 over 10 and 6 over 8. Are they the same fractions? No, so B and C are not similar. So that's worth a mark as well. So that whole question is worth 4 marks. 1 for saying A and B is not similar. 1 for saying B and C is not similar. Oh, actually, the question doesn't ask you for the not, does it? Okay, so no mark for that, no mark for that. 1 mark for A and C are similar. 1 mark for proving that with the sides. So it's only worth 2 marks, sorry. Because it doesn't ask you for the not, it just asks you for the yes.
If you don't show your working, you don't get.
Now, it would depend on, because it's only worth 2 marks, you would get A and C. It doesn't say prove, determine which, no. So you'd get 2 marks for A and C are similar. However, if I was giving that question in a test, I would make it worth 3 marks and say prove it why. If you circled A and C, I'll give you 2 marks. Because it doesn't say it, because it doesn't ask you to show the working, it doesn't have the marks. However, in a test, it would have the marks. If it was worth 3 marks, you'd need to say why. Okay? Yeah, so if it was only worth 2 marks and it asked for working, you'd only get 1. All right. The following are true or false statements. Oh, you're going to get lots of marks here, hopefully. Okay. Are all squares similar? Are all squares similar? Yes, because all squares have 90-degree angles, so the angles are the same. And all squares will have the sides in a similar ratio because they're all going to be the same each time, like it's 4 to 5 or whatever it is. So true, that's worth 1 mark. All triangles are similar. False, because angles can be all different within the triangles and so can the sides. So that's false. All equilateral triangles are similar. Equilateral triangles, if we think about them, always have all 60 degrees. Okay? And they're all the same length sides. What do you reckon the answer is? It's true. All isosceles triangles are the same. Now, isosceles triangles have 2 sides the same and 1 side different, which means it also has 2 angles the same, but they can be different numbers. What do you reckon? It's false because those numbers could all be different angles. They don't always have to be the same angles. I like to look at the angles first because it's an easier way of working out whether things are similar. If the angles aren't the same, they're not similar. The side ratios are a bit harder to find. All circles are similar. True, because it's just the radius, which is going to change, and so on. So it's true. All regular hexagons are similar. You need to know some words here, hey? Regular hexagons. Regular hexagons mean that all the side lengths are the same, and it means all the angles are the same. What do you reckon? True. Anything which is regular is going to be similar. Triangles with 2 pairs of corresponding angles are similar. Now, let's have a think about this. If you've got a triangle, and for example, this side here is 60, and this side here is 70, and you've got another triangle, and this side here is 70, and this side here is 60, what happens to the third angle? It's going to be the same. So you've got 3 angles the same. So are triangles with 2 pairs of corresponding angles similar? Yeah, because angle, angle, angle. So true. Triangles with 2 pairs of corresponding sides in the same ratio are similar. Now, in the answer key it says true. I think this is actually false.
It's like an isosceles. And you just said an isosceles wasn't.
Yeah, because we don't know what the other side is and we don't have the angle. It's about that angle in between it. So I'm going to say, I think the answers are wrong. I'm going to say false. Okay, and the reason for that is you could, if you had the angle in between them, because that would be side, angle, side. If you had the angle in between those two sides, yes, true. But because we don't know that angle and we don't know that length, we can't say that they are similar. Polygons with the same number of sides are similar. It's false because we don't know they're regular, because a polygon, like a pentagon, for example, could look like this. Hang on, let's not go to a pentagon. Let's go a kite could look like this, which is a polygon. And then that's still the same as a polygon is also a square. So false. All right, so that question, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That page is out of 11. Can you give yourself, I'll give your person a mark out of 11, please. All right, you are expected to know similarity tests. What are the 3 similarity tests we use? SSS, SAS, and AAA. They are the 3 rules to show similarity. What's the symbol for similarity? You need to know this too. The little squiggly lines. So if I said ABC is this to QRS, it's saying that they are similar triangles. All right. Hang on a sec. Okay. Use a similarity test to show if the 2 triangles are similar. Now, can we just put some letters in here because that'll make it easier? You are welcome to do that too. In your test, I will make sure that there are letters in this sort of question. Okay. Use a similarity test to show that they're similar. Now, you could actually use 2 of the different rules we know for this. Which 2 rules could we use to show these are similar? Angle, 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 and side, angle, side. Okay. We know. Why do you think we could use angle, 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 even though they haven't shown us the other angle? Because we can work it out. If we know 90 and 60, then we know this angle here is 30 and this angle here is 30. So it's up to you whether you want to say. Now, the reason why I put the letters in, now you won't have done this because we didn't put the letters in, but in your test you need to. If it says prove it, you need to actually show. So for this, you could either say angle, and I'm just going to use the single letters. You can use triple letters. Angle A is equal to angle P. Angle B is equal to angle Q. Angle C is equal to angle R. Therefore, triangle ABC is similar to triangle PQR. Angle, angle, angle. That's one way of answering it. Okay, so if you're using angle, 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 you need to say all 3 angles are the same and actually prove it. If you use side, angle, side, then you need to say the side length AB is in the ratio to PQ of 10 to 5, which is 2 to 1. Yeah? Everyone okay with this? The side length of B to C is in a ratio to Q to R of 17.3 to 8.65, which is a ratio of 2 to 1. And then they'd say angle B is equal to angle Q. Why did we have to use B and Q and not A and P? Why did we use the 90 degrees and not the 60 degrees? Because it has to be between the 2 sides. If you told me that the 2 angles 60 and 60 were the same in this, you wouldn't actually get the marks. Because side, angle, side is to do with the 2 sides and the angle in between. Girls, you all right? All right, so therefore, triangle ABC is similar to triangle PQR because of side, angle, side. So you need to say why. In this question, because you weren't given the letters, if you said the 2 sides are in the same ratio, you need to say something about ratio or say the ratio 2 to 1, you would have got a mark. And the angle being 60, you would have got a mark, and that's where your 2 marks would come in. Okay, if you said the 3 angles are the same, that's where your 2 marks would come in for that. However, in a test, I'll make sure there's letters there and you actually need to prove it in this way. Sam?
How many marks do they get? They do all the right things but not in the right order in terms of the sides.
Do you mean that 2 to 1, or do you mean that you just did it like you did the angle first and then? If you wrote like side, do you mean you did the 60, or if you use the 60, you'd lose 1 mark because you picked the wrong angle. Okay, so it needs to be side, angle, side.
And do you have to mention the 2? Like, do you have to mention the 2 to 1 to get a mark, or could you just say A, B?
You'd need to actually say the 2 to 1. So the ratio is actually really important. So 2 marks. Now, in this question, it says show if the 2 triangles are similar. No, so it's worth 3 marks. You then need to have your actual yes, it is. Sorry, guys. So you need to actually say they are similar because of side, angle, side, or they are similar, angle, angle, angle. So if it asks you to prove it, you need to give your reasoning why and then say yes or no with a statement. All right, next one. So 3 marks for each one. So I'm giving you a mark for saying the 2 sides are in the ratio of 2 to 1. I'm giving you a mark for saying the angle is the 90 degree is the same. Or you're getting 2 marks for saying all the angles and 1 for your answer, depending. All right, the next one is in the same way. You could use angle, angle, angle again, because this angle here is 110. And you know this angle here is 35. And again, it's 2 to 1. So it's exactly the same working out as before. And they are the same. Can you guys see that? Do I need to write it out? Yes. So for this, they are similar. I'll just write it how you'd probably do it because you don't have letters. They are similar, which is worth 1 mark, and either side, angle, or angle, angle, angle. That's worth 1 mark. Depending on how you do it, the ratio of 2 sides are 2 to 1, and same angle is 35 degrees. So that's your 2 marks there. Or you could have said all 3 angles are the same. 110, 35, 35. So that's worth your 2 marks. Everyone okay with that? All right, last one. Side, side, side is the only thing we can use because we don't have anything else. Now we need to check which one is related to which one. So we can't just assume that because they're in the same order they are. So smallest number. Guys, could I get you to stop talking because this is actually worth quite a bit of marks in your test and some people don't understand it. So smallest number to smallest number. So it is in the same order, but I would actually highlight them as they go just to make sure. So we're saying those ones need to be in the same ratio. So 12.5 divided by 5, 20 divided by 8, 25 divided by 10. So this is 2.5, this is 2.5 is 16, 2.5. So they are similar. So you get 2 for that. They are similar. Side, side, side. Can everyone see that?
You have to mention the side, side, side.
You need to mention the side, side, side.
So you can't just do like triangle ABC.
No. So if it asks you to prove it or to show it, you have to show why. So you have to nominate which rule you're using. Because otherwise, the only other way you could actually get away with this is if you show all 3 angles are the same and all 3 sides are in the same ratio. If you show those 3 things and say, yes, it's similar, that's okay. But if you use one of these rules, you're actually bypassing checking every angle and every side. And so you have to show what rule you're using. All right, so that page is worth 9 marks. So give yourself a score at bottom at 9. Is the bell about to go? All right, I just want to finish this last page. We're going to go really quickly. I'll give you a set of solutions. A map has a ratio scale of 1 to 25,000 if the distance between 2 locations is 10.5 centimetres. All you need to do is times it I need you to stop talking, guys. Is times it by 10.5, and we end up with 2625000 centimetres. It will be in the same measurement as whatever you measured it in. If you then needed to convert to kilometres, we need to change to metres, which is moving by 2 decimal places. So this would get you to 26250 metres, and then to get to kilometres, there's 1,000, so we're dividing by 1,000, and so you end up with 26.25 kilometres. So 1 mark for your kilometres, 1 mark for your centimetres. If you got the kilometres, you get both marks. All right, convert the following. Now, I don't think I've used the word explicit scales into ratio scales. That just means it needs to actually be a ratio, so the same measurement. So your answer here is 1 to 30,000, because it needs to be in centimetres. So just saying 1 to whatever it is. What is the actual ratio? The next one is 500 to 5, which is the same as saying 100 to 1. I am keeping you for 2 minutes. I hardly ever keep you in. I need you to make sure you do this well. So we changed it to the same measurement, and then we simplified it. So you got a mark for the 100 to 1, a mark for the 500 to 5, or if you got 100 to 1, you get 2 marks. Next one is 3 to 6,000. So it's in the same measurement, which is the same as saying 1 to 2,000. So again, you can get a mark for this and a mark for that, or if you get your final answer, you get both marks anyway. And the last one says 24 to 7200000. You need to simplify it. So that's 1 mark. You need to simplify it to 1 to 300,000. That's your second mark. Last one. If a basketball court measures 25 metres by 15 metres exactly, how would each dimension be on a scale drawing using a ratio of 1 to 2,000? 200, sorry. So basketball court measures, so the ratio is 1 to 200. So if we look at the 28, we're saying it's in a ratio of 1 to 200. We need to go, okay, so a number divided by 28 equals 1 to 200, which means that x equals 0.14. You've got to divide it by 200 to get how much it is. So it would be 1.25 metres. So if we're making it smaller by 200, 0.14 metres is fine. That would be one answer. And your other one would be would be 0.075 metres is your second answer. That question's a bit confusing. That page is out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 11. Can you give yourself a score? Or your partner a score? Yes.
On the last page, could you put that in centimetres?
Yes. Centimetres would have been completely correct. All right.